Welcome to lecture number 91A of digital electronics. In lecture number 91, we have dealt with conversion of SR flip-flop to JK flip-flop. So here, what we have done is we have done with realization of realization of JK flip-flop using SR flip-flop. So S is written in terms of J, K and Qn, and similarly R is also written in terms of J, K and Qn. And we have done with the present state next state table of JK flip-flop and given with the excitation table of SR flip-flop. So here what we have derived is we have derived the relation between S, J, K and Qn. Similarly R, J, K and Qn. We have derived the equation as S is equal to J Qn bar and R is equal to K Qn. And here what we are having, here we are having an SR flip-flop. This SR flip-flop is having output as present state and complement of present state. And what is S? S is equal to J Qn bar. So Qn bar is coming out, you have to add it. And what is K? K is equal to R in what is R? R is equal to K into Qn. So K is coming in and Qn is coming here. That is added and given to R. Okay. So that is how we are converting this SR flip-flop to JK flip-flop. In this lecture, we are going to deal with conversion of SR to D flip-flop and SR to T flip-flop. So conversion of SR to D and SR to T flip-flop. So coming in the first one, conversion of SR flip-flop to D flip-flop. Conversion of SR flip-flop or to D flip-flop, or what you can write is realization of D flip-flop using SR flip-flop. We can write it in both ways. Okay, the previous one what you can write realization of JK flip-flop using SR flip-flop. Okay, this we can write it as realization of JK flip-flop using SR flip-flop. Now, here what you need to you need to convert SR to D flip-flop and SR to T flip-flop. So here what you need to write here, what you have got the expression. You have to write the expression of S in terms of J, Q and okay. So if you are converting SR to D flip-flop, you are having D flip-flop. Okay, SR to D flip-flop. So you need to get D flip-flop. So required flip-flop is D flip-flop. Okay. What we have in hand is SR flip-flop. Therefore, now for this D flip-flop you are having Qn and Qn bar. Therefore, we should write S in terms of D and Qn as a function of D and Qn. Similarly, R also as a function of D and Qn. Okay, or Qn bar, whatever it is. Okay, so that is our intention. Now coming into the truth table of this D flip-flop. Okay, so we are having, I will write D and present state. Present state is Qn. So it is 0 0 0 1 1 0 1 1. So what will be the next state? That is Qn plus 1. Next state is Qn plus 1. From there we are deriving the S and R. S and R is taken from the excitation table of this S and R. 0 to 0. So what is the basic truth table equation for this D? We can write Qn is equal to D. No, Qn plus 1 is equal to D. So what you can write 0 0 0 0 1 1 1 and 1. Okay. Now coming into S and R. If present state in S state is 0. 0 to 0 means 0, don't care. 1 to 1 means don't care, 0. 1 to 0 means it is a reset. So 0 1. 0 to 1 means it is set. So it is 1 and 0. Now you need to write the expression for this S and R in terms of D and Qn. That is it. So how do you write? How do you formulate the expression for S in terms of D and Qn? Okay. So here I am having a 4 variable this one. So here I am having a 2 variable K-map. That is I am having D is here, Qn is here. So it is 0, 1, 0, 1. Now it is 0, 0. What is S? 0, 0 means S is 0. I am going to find the expression for S. 0, 0 means 0, 0 means S is 0. 0, 1 means S is 0. 0, 1 means S is 0. 1, 0 means S is 1. 1, 0 means S is 1. Then 1, 1. 1, 1 means S is don't care. S is don't care. So here what you can have, you can club these two. You can club these two. Okay. So this is D bar, D, Qn bar, Qn. And if you are clubbing these two, what do you get? You will get S is equal to D. You get S is equal to D plus. Now, how to find this R? For R, you draw another K-map. I'm going to find the expression for R. So R means here you need to draw a two variable K-map. So it is again D and Qn. So 0, 1, 0, 1. So this is D bar, D, Qn bar, Qn. 0, 0. R is don't care. 0, 1. R is 1. 0, 1. R is 1. 1, 0. R is 0. 1, 0. R is 0. 1, 1. R is 0. 1, 1. R is 0. So what we can combine? Here we can combine these two. Here we can combine these two. That means what do we get? R is equal to D bar. You will get R is equal to D bar. So now what I have done, I have written S and R in terms of D and Qn. Of course, Qn is not there. So how do you redraw the circuit? So here you are having S, R flip-flop. This is Qn. This is Qn bar. And the input is D. So what do you get? D is directly S. D is directly S. And R is D bar. R is D bar. Yeah. We are having a clock, of course. Okay. This is Qn and this is Qn bar. Okay. This is how we are converting this SR flip-flop to D flip-flop. Okay. Now coming into the last one. Last one is conversion of SR to D flip-flop. SR to D flip-flop. Okay. So what you have is SR flip-flop. What you require? What you required is D flip-flop. Okay. Now for this D flip-flop, we are having T, Qn and Qn bar as output. So here what you need to write? You need to write S as a function of T, Qn or Qn bar. R also as a function of T, Qn and Qn bar. Okay. Now, first of all, let me write the truth table of T. First of all, we will write the truth table of T. So T and Qn, T and present state. So 0, 0, 0, 1, 1, 0 and 1, 1. So what will be the next state? That is the question here. Qn plus 1. After that I am having S and R. 0 to 0, no change. So T 0 means it is 0. 0 to 1, 1. 1 to 0, 1. 1 to 1 it is 0. So if it is S and R, 0 to 0 means 0, don't care. 1 to 1 means don't care, 0. 0 to 1 means it is set. So it is 1, 0. 1 to 0 means it is reset. That is 0 and 1. Now you need to form the expression for S in terms of T and Qn. That is it. So it is basically a two variable K-map. So I am going to find the expression for S. So it is T, Qn, T and Qn. Yeah, it is 0, 1, 0, 1, T bar, T, Qn bar, Qn. So here what do we get? What is as 0, 0? It is 0, 0, 1, don't care. 1, 1. Yeah, this is, yeah, oh sorry, 1, 0. 1, 0, it is 1. 1, 1, it is 0. 1, 1, it is 0. So here what you can have? Here you can have only this element. Here we can have only this element. So what is that? That is T Q n bar. So what we can write? S is equal to T Q n bar. Only one is there, so we can write S is equal to T Q n bar. Now I need to give an expression for R also. I need to find an expression for this R. For R also I am drawing the truth table. This one K map, the truth table K map. In terms of T and Qn, this 0, 1, this T bar, T, 0, 1, Qn bar, Qn. So it is 0, 0, R is don't care. 0, 1, R is 0, 0, 1, R is 0, 1, 0, R is 0, 1, 0, R is 0, 1, 1, R is 1, 1, 1, R is 1. So we can take only this one, right? So what is the expression? This T is there and Qn is there. That is R is equal to T into Qn. So how do you draw the logic circuit for this? What we are having is SR flip-flop. We are having an SR flip-flop. Anyway, clock is there. Clock is there. What is S? This is Qn and Qn bar. Input is T only. What is S? S is equal to T Qn bar. This is AND gate. And here I am having Qn bar. S is equal to T Qn bar. What is R? R is equal to T Qn. Having another AND gate. So having T is there. And Qn is coming back. Yeah. And that is R. And we are taking Qn and Qn bar out. So this is Qn and Qn bar. So here we are having a combination circuit here, and this is the actual flip-flop. Okay. So here we have converted SR to T flip-flop. So if the conversion is from SR to T flip-flop, the base flip-flop what we are having is SR, and S and R should be written in terms of T. Okay. That is on the basis of the truth table of T and excitation table of SR. Okay. Here the conversion is from SR to D. That is again from the truth table of D and excitation table of SR. And in the previous lecture we have done with conversion of this SR to D. Then SR to JK also, that is completed. Okay. So that is regarding conversion of SR flip-flop to other flip-flops. And in the next lecture we will deal with conversion of this JK flip-flop to other flip-flops. Thank you.